In earth science, we generally talk about brittle and ductile deformation. Brittle deformation is associated with cold rocks in the upper crust and things like earthquakes and faulting, while ductile deformation is often associated with mantle rocks or hot rocks, things that can squeeze and plastically deform, or glaciers, because remember, ice is a mineral. So we've got a creep apparatus here that you can do experiments in your classroom to determine things like the creep exponent and help your students understand ductile deformation. When you open the box, you're going to find the creep apparatus. You're going to find some wax cores that you're going to use. Paraffin wax is commonly used as an analog for earth materials because it lets us run these experiments pretty quickly. And you can order extras of these on the website. You're going to find a USB cable to connect to your computer, a calibration certificate that tells you how the displacement was calibrated on this instrument, and a pair of vernier calipers. So first, I'm going to take my calipers and measure the length of my core. And I'm getting 51.1 millimeters here. Now we're going to insert the core. So I'm just going to lift the plate and insert the core, trying to get it centered. And I'm going to take the USB cable and plug it into the circuit board and into my computer. You'll see a green light come on indicating that the creep apparatus is receiving power from your computer. You can use the free software on our website or a serial terminal of your choice to record data. I'm going to use the software from our website. So I'm going to go ahead and select the serial port. I only have one showing up here. I'm going to click Connect. We get a green light there, and we see data start scrolling across our screen. If I move the plate, we can see that we get a change in our displacement reading. Okay, so I'm going to go ahead and hit Clear, and that clears the chart and lets us start again. When I hit Save, it's going to save the data that are on the chart currently. We've got experiments over here, and we've got instructions on the right-hand side here just in case you forget. Okay, so now you need to provide a weight. We recommend 10, 20, and 30 pounds as good weights for paraffin wax cores. I've got a 10-pound gym weight here. So I'm going to go ahead and place it on the plate, and I'm going to hit Clear so I get a good starting point. Now this weight is going to ductily deform that wax core. We recommend letting it get to a steady state because there's going to be an initial rate of deformation and then it's going to roll over and get to a nice steady state of deformation. That could take 10, 20, or even 30 minutes. With a lighter weight like 10 pounds, I anticipate that we're going to need to let this run for closer to half an hour. So we'll do that and come back and check in on it. So now that we've let this run for a while, we can see that we've got a nice linear trend that we can fit. Your students can save the data out of this software and analyze it in Python, MATLAB, Excel, whatever they'd like to use. You can print out the graph and analyze it by hand, and you can even load in previous experiments into the software. The Creep Lab activity comes with a pre-written lab activity that has values from the literature for paraffin wax creep exponents that your students can compare to, questions, explanations, and more. It's an editable Google Doc and it's available in the product description. The Creep Lab activity makes an excellent addition to any undergraduate structural geology program or even material science programs. You can pick it up today at the link down in the description, as well as subscribe to our newsletter for updates, sales, and more.